Good day, everyone. Once again, I welcome you to another episode of Organic Chemistry. And in this particular season, we'll be dealing with uh, a lot of things related to carbon. And the major one we'll be dealing with there is the history of organic chemistry. And apart from the history, we'll be talking about the position of carbon in the periodic table. We'll be talking about chemical bonding in organic chemistry, characteristics, talking about the physiochemical properties of organic compound. We'll be dealing with homologous series. We'll talk about functional group in the in organic chemistry, classification of organic compound, and IUPAC nomenclature, which was adopted in the year 1957. Please take note. IUPAC simply means International Union of Pure and Applied Chemistry. Please, it's not apply, it is applied chemistry. So this is actually another examination question. It was the full meaning of IUPAC, International Union of Pure and Applied Chemistry, and this systematic name of organic compound was adopted in the year 1957. So these are some of the things to be dealing with. But first of all, let's talk about those that contributed to the periodic table. A lot of scientists from different countries in the world actually contributed, to organic chemistry. A lot of scientists contributed to it. The position of carbon, how carbon react, the reactivity, even the definition of organic chemistry was actually contributed by a lot of scientists. And the first person that talked about organic chemistry is Lemery, who is a French chemist. Then after him, we have Torbjörn Bergman, who is from Swedish, a Swedish chemist. We have Berzelius, a Swedish chemist as well. We have Wohler, is a German chemist. We have Kolbe, a German chemist. We have Brown, that's a Scottish chemist. We have Lewis. I believe that you have heard of Lewis before. Lewis structure, that's dot structures. So he's from United States of America. We have Van Hoff, who is from Dutch. Then we have Lebel, who is also a French chemist. It is wrong for me to write everybody without naming someone from Nigeria. So let me quickly add someone else to it. We have Guido Academy, who is a Nigerian chemist. So these are some of the names that contributed to the organic chemistry we are seeing today. So please take note of that. So let me quickly start with position of carbon in the periodic table and chemical bonding in this particular video. So we'll be working with the first group 8 element, group 1, group 2, group 3, 4, 5, 6, 7, and here is what? 8. So if I should place hydrogen here, helium will be here, lithium, here is beryllium, here is boron, here is carbon, nitrogen, oxygen, fluorine, and here's what? Here is neon. So we know that carbon belongs to group 4. Carbon belongs to group 4 in the periodic table. This is carbon here. And carbon belongs to period 2 in the periodic table. The 3 elements before carbon in the periodic table, we have 3 elements before carbon atom. Then we have another 3 elements after carbon atom. Let's ignore this one because we know that one is not reactive. Neon is a noble gas, and noble gas usually we believe that they are not what? Reactive. So let's remove noble gas from this reaction. So we have 3 elements before carbon and we have 3 elements after carbon without listing this one here, neon. So the 3 elements before carbon are lithium, we have beryllium, and what? Boron. While 3 elements after carbon, we have nitrogen, we have oxygen, and we have what? Fluorine. I'm going to come back to this. The electronic configuration of carbon is 1s2, 2s2, and 2p what? 2. Please take note, this is a ground state electronic configuration. We have what we call excited state electronic configuration of carbon, which is 1s2. One of the electrons here will be excited to the 2p. So you are going to have 2s1. The reason for the excitation, or the reason for moving from this energy level to a higher energy level, is simply because one of the electrons in s orbital has gained enough energy. So when you gain enough energy, when that electron gain a particular energy, you'll be like, I can't stay in this quantum number again. There's need for me to move. So I can't stay in this orbital again. There's need for me to move to a higher orbital. So one of the electrons will be promoted from the 2s orbital to the 2p. While the 2p will become what? 3. So this is the excited state of what? Of carbon. Carbon also have what we call the hybridized state, whereby one s from the 2s orbital will blend from 1s from the 2p orbital. So you can either give us sp, sp2, and what? sp3. So we are going to deal with this maybe probably in our next video, so that you understand what hybridization is all about. Carbon actually has a lot of characteristics. Carbon can catenate, it hybridizes, a lot of characteristics. So please, probably in our next videos or subsequent videos, we'll be talking about mostly on carbon. But in this particular video, let's talk about the position of the carbon in the periodic table and the chemical bonding. So the three elements before carbon, which is lithium, beryllium, and boron, if they want to be stable, remember, for stability of elements, we believe that they have to gain, lose, or share electron. So these are the three criteria that will enable a particular element to be stable. So the three elements before carbon atom, before carbon, which is lithium, beryllium, boron, what will happen there is that they will transfer electron. They transfer electron, and as long as there is a total transfer of electron, what kind of bonding takes place there is what? Electrovalent bonding. So the three after carbon, they undergo what we call electrovalent bonding. Why the three? This one, they transferred electron. Please take note, they transfer, which is the give out electron. Why the three after carbon? What they do is that they can actually accept electron. Please, they can actually, that means the other bond might be there, but the major thing is that they can actually what? Accept what? Electron. And as long as they can accept electron, we believe that electrovalent bonding can also do what? Take place. But they can undergo other reactions like sharing of electron and all that, because they are non-metal. But the carbon atom you are seeing here, like what I said, these three here give out electron. These three here, they accept electron. But the carbon atom you are seeing here, it doesn't give out electron, it doesn't accept electron. What carbon does? It shares electron. For example, we are going to see a carbon atom here. The electronic configuration of carbon, or we believe that carbon has 6 proton number, 6 neutron number, 6 electron number. So if you want to draw the share, the first share is 1, 2, while the second share is 1, 2, 3, 4. So for this carbon to be stable, it needs 4 electrons. And there is no element in the periodic table that is ready to give out 4 electrons to carbon. So what carbon does is that, let's say hydrogen will be bonded here, another hydrogen will come here, another hydrogen will come here, sharing of electron, another hydrogen will come here. If you look at the hydrogen here, hydrogen will be what we call the duplet rule. So that's to say the hydrogen is stable. And if you count carbon 1, 2, 3, 4, 5, 6, 7, 8, the carbon atom is as well stable. So this structure will now be carbon, hydrogen, 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 and here will be what? Hydrogen. And this is what we call methane. This is a methane structure. So that is it for carbon. So please take note, the three elements before carbon, they actually undergo transfer of electron, which is gaining of electron, sorry, losing of electron, they give out electron to others. Why this one? The three elements after carbon, they actually accept electron. But please, they can undergo all that form of bonding, but the major one here is that they accept what? Electron. But carbon doesn't give out electron. Carbon atom doesn't accept electron. What carbon does is what? It shares electron. And because of the sharing of electron, carbon is covalently bonded to other what? To other elements. So the kind of bond that carbon atom undergo is what we call covalent bond. So that is generally everything about the history, or the introduction rather, to organic chemistry. This is actually an introductory class to organic chemistry. Probably in another class we'll be going deeper and deeper, but please take note, I'm just introducing organic chemistry and I'm just introducing carbon position in the periodic table. I repeat, we have Lemry, we have Toba Bergman, Berzelius, Wohler, Kobe, Brown, Lewis, Van Hoff, Lebe. Please, it is important you take note of the country they are from. Like Lemry, I said, is from French. Why the last name there, I said Lebe, is also from what? From French. If you have any question based on what I have said so far, please feel free to drop that in the comment section. But I have a question for you. Carbon, nitrogen, and boron. Which of them has the highest value of highest value of electronegativity? Electronegativity. So please, if you know the answer, drop it in the comment section. Carbon, nitrogen, and boron. Which of them has the highest level of electronegativity? See you in our next episode.